Let's take a moment to read the problem. The recommended dose of a drug is 20 milligrams per kilogram per day. A child weighs 16.3 kilograms. How many milligrams of this drug should the child receive each day? In this problem, we are dealing with three different labels. They're all here together: milligrams, kilograms, and day. In a proportion, we only have room for two labels, so we're going to look at which of these three is going to remain constant. So I have the 20 milligrams per kilogram, which would be per 1 kilogram per day. I'm given the kilograms. I'm asked about the milligrams, and that is per each day. So the time, again, the day, is constant. So I can set up my proportion without the time, because that does not change. That is not proportional to anything that is constant. In my first fraction, I am told that they should get 20 milligrams per kilogram, and that has an unwritten 1 with it. And then I'm asked how many milligrams, so I'll use X to represent that, if they weigh 16.3 kilograms. Completing this problem is very straightforward. My milligrams and kilograms match in each of my fractions, so I multiply on the diagonals. With the help of my calculator, the first diagonal gives me 326 milligrams, and the second diagonal gives me 1x, or just x, so I have immediately solved. So the answer to the question, 326 milligrams per day. This problem, I think, is actually easier if we use dimensional analysis. I won't show you that this week, though, because our focus here is on proportions, and we don't want to confuse the two concepts. In the proportion, we always want the label on the top to match the other label on the top, the label on the bottom to match the other label on the bottom, and between our two fractions is the equal sign.